for 19 December, the week of 19 December. We'll be looking at day 1 and day 2. Well, problem number 1 we did in class today, so I'm going to move down and look at problem number 2. We're trying to find the equation of a line for this particular line right here. We're looking for the slope and y-intercept. Well, we know our slope-intercept form. Slope, intercept, form. Slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. Well, we're talking about this line right here. First, I will identify the y-intercept. Well, this point right there, that's the y-intercept. It's the point where the line crosses the y-axis. This point appears to be -1, 2, 3.5. That point is -0, -3.5. That is my y-intercept. Therefore, in my form, y equals mx plus b, b will be this -3.5. Here I go. Y equals, m I don't know yet, I'm simply going to leave a blank, times the variable x. Y-intercept -3.5, so I will say subtract 3.5. I've just found b, my y-intercept. Now I want to find this slope. You may remember that slope is equal to change in y divided by change in x. Well, we simply need 2 points to find that. So I'm coming with my table. X coordinates and y coordinates. I see I have 0, -3.5. I'm not going to use that point. I'm going to use points that are a little better defined, like this point right here. Over 1, down 1, 2, 3. 1, 2, 3. That point is 1, -3. Now I'll use this point. Left 1, -1, down 1, 2, 3, 4. That point is -1, -4. So I want to look at the change in x and the change in y. Well, this change here from -3 to -4 is down 1, -1. Well, from 1 to -2, that is a decrease of -2. 1 to 0 and 0 to -1. So my change in y here is -1. My change in x is -2. We'll substitute those two values in. Change in y, -1. Change in x, -2. -1 divided by -2, that is a positive 1/2. And this positive 1/2 is my slope. It will go here. 1/2. So y equals 1/2 x minus 3.5. That is my equation. Slope is 1/2. The y-intercept is a -3.5. All right. You can use that same process to answer the 2 problems here on Tuesday. Pause the video at this time and take a shot at one of these problems. Okay, we're continuing on with the Tuesday problems. I'm going to look at this problem in the bottom right hand corner. Again, we're using our slope-intercept form. Y equals mx plus b. Where m represents the slope and b represents the y-intercept. I will first identify the y-intercept. On this graph, the y-intercept is this point right here. The point where the y-axis and the line intersect. And that point is 0, 1. Therefore, this 1 will be substituted in place of b. New equation. Y equals, I don't know what the slope is, blank, variable x plus my y-intercept is 1. We have just identified the y-intercept to be 1. Now we need to find the slope. Slope, which we use m to represent slope, is the change in y divided by the change in x. Well, we need 2 points. We have 0, 1. We need one other point. They're giving us this point. I can use, yeah, that looks like the best one to use there. This point here. Negative 1, 2, 3, 4, up 1, 2, 3, 4. So we have 2 points now. X and y. One point is our y-intercept. 0 pairs with 1. The other one, negative 4 pairs with positive 4. Negative 1, 2, 3, 4, up 1, 2, 3, 4. I want to find my change in y, change in x. Alright. From 1 to 4, this change here is plus 3. From 0 to negative 4, that's going down. That's a negative 4. So we went up 3 in my y, down 4 in my x. So change in y, plus 3. Change in x, negative 4. 3 over negative 4 is exactly that. It's a negative 3/4. We typically express the negation with the numerator. So this negative 3/4 is my slope. My final equation is this. Y equals slope negative 3/4 times x, y-intercept plus 1. Y equals negative 3/4 x plus 1 is the equation of this line. Notice the line is moving down. That's because the slope is negative. If I wrote my name on this line, you can see that my name is moving in a downward direction. Alright. That concludes the problem on Tuesday. You should now be able to work this problem. We're now looking at day 3. Determine if the mapping is a function. Then we're going to write, is it a function or isn't it? Well, you may remember our definition for function. Function. A relation where each input, that is the x, goes to a unique output. The output is the y variable. And we remembered this phrase, no confused x's. That is, every x must know where it's going to. One x cannot go to more than one y. So I'm looking at these two mappings. We have one pairing with 3 and one pairing with 4. You can see that indeed one is confused here. One goes to two different. That one is pairing with two different ones. So our A here, A, not a function. It is not a function because 1 is pairing with 3 and 1 is pairing with 4. You can see that 1 has two different assignments. 1 is confused, we might say. Therefore, this relation is not a function. B, it is a function. 1's pairing with 4, 2 pairing with 3. 3's pairing with 4, 4's pairing with 5, 5's pairing with 6. You can see both 1 is going to 4 and 3 is going to 4. That is not a problem. Each one of these x's know where they're going. It's okay to have a repeated y, but the x having more than one assignment is the problem. So in B here, function. Using my definition, each x goes to a unique y. Only one y. Alright? 1 is only pairing with 4. 3 is only pairing with 4. It's okay that we've used 4 twice, but it is not okay that 1 has 2 different assignments. Alright. Write each number in scientific notation. Well, with scientific notation, we write the number such that it's written as a number between 1 and 10. And we simply are going to indicate the number of places we move the decimal. In this problem here, we moved it 1, 2, 3, 4, 5, 6, 7 places. So we write this as 7.86. And then we write times 10 to how many places we moved the decimal. 1, 2, 3, 4, 5, 6, 7 times. And since we moved it to the right, that is, it's a very small number, a number close to 0, it's 7.86 times 10 to the negative 7th. Contrast that to number 4. The decimal is currently here. 1, 2, 3, 4, 5, 6. This is equal to 1.26 times 10. And we moved the decimal 6 places to the left, so it's a positive 6. 1.26 times 10 to the 6th, 7.86 times 10 to the negative 7th. Determine the slope from the two given points. Well, we can use our slope formula. Our slope formula, m, is equal to the change in y divided by the change in x. Well, we could convert to a table as we had previously. I'm going to come over here and show that. Perhaps seeing the table will help you figure these out. 19 pairs with negative 16. Negative 7 pairs with negative 15. I'm simply going to look at my change in y and change in x. From negative 16 to negative 15, that is an increase of 1 plus 1. From 9 to negative 7, I hope you can see it's going down. It's going down 26. To find that, you would simply subtract negative 7 minus 19. Negative 7 minus 19 is a negative 26. Decrease in 26. So slope is change in y divided by change in x. The slope between these 2 points is a 1 over 26. We could write the negative here, but we typically express the negative with the numerator. It's a negative 1 over 26. Using that, see if you can complete those problems.